Today is another fairly important lecture. I think that I mentioned this in a previous class. The three primary concepts of object-oriented programming are polymorphism, inheritance, and encapsulation. So if I haven't, there you go. Of which right now, the most important one, and the one that we've already discussed a couple of times, is encapsulation. You want to hide things from your users. You want to provide, we talked about the facade design pattern, you want to provide a front to them and not necessarily let them go and mess around with the inner workings of the classes that you're writing. Okay, the idea is to keep things simple for them, and sometimes that requires you to protect the data of a class. Okay, so along those lines, encapsulation goes along with the concepts of composition and aggregation. So before I define those, let's go to a blank slide and talk about how we might, several different ways that we could build, I don't know, a person class, something simple. In fact, we discussed some of this when we were talking about 2D arrays. Some of the things that we could store about a person, we could have an integer that represents their age, we could have a string that represents their address, maybe a string or perhaps even an integer to represent the phone number, maybe a long for social security number, whatever.
Name?
Yeah, I guess we did need a name. That's a good
This is
idea.
under what of the three parts?
Say again?
This is under what of the three parts, like you were talking about encapsulation?
This is going to be go along with the concept of encapsulation.
All right, cool.
Okay? String, name, etc. I'm sure that we could come up with all kinds of different stuff. That's one way that we could build the person class. And of course, we would want to make all of these variables be private, so that the idea is the only way that they can change the contents of these variables is either they can only do it through the constructor, that's if we make the object be immutable, or we can also provide some set methods to let them, change the age. Every time birthday comes around, we might want to have a method that allows them to increment the age. They can't just go there and change it to whatever they want. They have to call a method for that change to occur. So even if we decide that the class should not be immutable, some of this stuff will change, like addresses change and phone numbers change. Even if it's not an immutable class, we're going to make those variables be private and force the user to make changes by calling methods. Why is that helpful? Well, if they, instead of letting them directly access the address and making it be the empty string, we make them call a setAddress method where we check the thing that they're trying to change it to and make sure it at least makes some reasonable sense. That doesn't mean they can't still mess stuff up, but at least we can do some basic checking to make sure what they pass to that method and what they're trying to change that variable to be gets scrutinized a little bit. Okay? So this is one way we create a person, and I mentioned that even though string is a class, and that's why it starts with a capital S, whereas integer and long are just primitives and they start with lowercase, string is kind of in between being a primitive. It's got some primitive characteristics, it's got some object characteristics. So I generally would say, I guess my tendency is going to be in this class, if we have a list of primitives and strings, then I'm going to say that all those variables are essentially primitives. Okay? So we could define a person with this stuff and perhaps more. On the other hand, we could also come along in here and say, so this is getting us to the composition and aggregation stuff, that I would like to have, in fact, let's just call it an address. So the address itself could be broken down into several components. So we could have said street and number, have a string, that's the state, I don't know, have an integer, that's the zip code. We could have done all that. Okay? But we want to learn about composition. So instead of having the person contain all essential primitives, we're going to be smart and say, well, these things are kind of related. we're going to write a class called an address class that contains those things. And then the person class is going to reference an address rather than those three components separately. Okay? So, how do we want to do this? I guess new slide. All the other stuff, and then we've got an address. That is essentially this concept of composition and aggregation, where you have one object that is built out of other objects. Okay, your simplest objects, your simplest classes will probably have all primitives for the instance variables. Okay, of varying types, characters, booleans, strings, whatever the case may be. But as you start building more and more complex objects that are composed of these simpler ones, eventually you have objects that are built almost completely out of other objects. So I'm going to use those two terms interchangeably, but there's a subtle difference between composition and aggregation. Aggregation implies that the objects can exist on their own, versus the objects are an essential component and do not exist on their own. This, in my experience, this is kind of rare. Okay, I guess if I sat here and I tried to think of some examples of, and I'm building up a complex object, and it's composed of a bunch of simpler objects, but those simpler objects I would never need to create on their own. I would only ever use them as part of this more complex thing. Okay, maybe I could take some time and think of an example, but that's actually, in my experience, pretty rare. By far and away, the more common thing is, yeah, I decided to write this more complex object out of these other objects, but I could have used those by themselves in other places. Okay? We don't have to have an address object that only appears inside the person class. There are other ways that we can use address, maybe even by itself, but place it in other objects, whatever the case may be. Okay? So, technically speaking, those two ideas are different. I like the word composition. That's probably the one that I'm going to use. I'm going to use them interchangeably. So most of the time I'll actually be talking about aggregation, but I'm just going to say composition. Okay? So anytime that you have an object that's built out of other objects, we're talking about composition. Okay? Even though technically that's not quite correct. Okay? So I hope that doesn't bother you. But to tie that into encapsulation, even though we have an object that's built out of other objects, all those objects had better be private. Okay? We still, if we decide to make the thing not be immutable and we want to allow users to change the contents, which in this case is going to be changing objects around, we provide set methods to do it. Okay? But we have to watch out a little bit for a reason that I'll talk about now. Let's go back to our person and our address here. Okay, so suppose we got a constructor which accepts an address. And of course we remember to make this thing private so we don't lose points on the first test. Okay, so if you have no clue what it should be, make it be private. Okay, how do we set that? Well, remember what the keyword this refers to. If it's used with a method, it's the calling object we're talking about. Okay, myself, essentially. If we're using it with a variable, that means we're talking about the instance variable, not the local variable. Okay, so this dot address in this case is talking about our instance variable. even though they have the same name, we can distinguish between the two of them. If I leave that off, it's going to think I'm setting the local variable to be what it already is. So compiler will just be happy, but it probably isn't going to work right. Okay? So I need this dot in the case that I have a naming conflict to distinguish between an instance variable and a local variable. So what have I done here? So somewhere there's a main method where I created a person. First I created an address. It's equal to new address. And I provided a street and a zip and all that other fun stuff. So address contains all the fields that you would expect. Street, state, town, zip code, all that stuff. And I create a person. And the constructor says pass address. Okay? Now I've got a potential problem. And here's my problem. Let's go to a new slide. So here's street, city, state, zip, whatever. Okay? I have a variable in my driver. Let's call that, let's call it address 1 to distinguish it from the other stuff. So I need to pass address 1 here. I've got a pointer to it. Okay? I pass that address into my person. So I have that instance variable address. So this is inside person class. It's got a pointer that points to that thing. I really wanted to make this class immutable. I wanted to make sure that none of those values, that's the old version, none of those values can be changed, including age and all the other stuff, birth date, maybe, whatever. Okay? So I make address be private, but unfortunately I have a problem. What's the problem? It's not immutable. They're both pointing the same thing. So this is what I want. I want my object to point to that address, but the user still has a reference to it through the variable that they created in the driver, which you can't really tell. It's supposed to be address 1. Now I'm making it worse. Okay? They still have a reference. They created the address object. They passed it to the person class, but they still have a pointer to it. Okay? So if I was trying to make an immutable object, I'm going to be in trouble if my user really wants to mess my stuff up. They can use the address reference they have to come in there and change those values to be invalid later. Just wrong, whatever. Okay? So I really shouldn't do this step. Oh, by the way, we actually had another variable. We had the instance variable, let's call it IV, and we had local variable, LV. Okay, what happens to local variable? Yeah, it doesn't get garbage collected, so let's talk about that for a second. It's not garbage collected because new was not used for that variable. Okay, we created a new variable which is a pointer. So it's just like an integer contains a number, a Boolean contains true or false, a pointer contains an address. So it's just like any of those other local variables. It simply vanishes when the method finishes. Okay, I'm not garbage collecting any objects, just the variable, just like all the other integers that I declare locally, they're gone when the method ends. Only it's a pointer variable that used to contain a memory address. Okay? So it's not garbage collected. You garbage collect stuff that you used new to create and then abandon later. Nothing's to stop me from creating all kinds of addresses here in my driver class and have address 1 initially point to the first one, then I move it to the second one, which that's now got to be garbage collected. Then I move it to the third one, that one's got to be garbage collected, etc. So you can change what a pointer points to, and if you abandon so nothing else points to one of those old objects, then you got to do garbage collection. But pointer variables themselves are just gone. They're not garbage collected. Now, when you get to assembly, we'll talk more about how that actually happens, but for our purposes, that's good enough for now. Okay? So the local variable is going to go away when the method finishes. So once the method completes, this is the situation that I'm looking at. So because I still have a reference left to that thing, what should I do here instead? In here. So instead of simply doing that, that's not going to be good enough. Okay? I need to make a copy of that thing. So I need to create a new address and copy the name into it, the street address, the state, the city, the zip. I need to copy that information into it so that I make a new address in here. So this dot address is equal to new address with stuff in it. And so then my picture will look like same information is there, street, city, state, zip. So they're identical, only that one points down here now and not there. Okay? So that way, if my user who still has a reference to that original object decides to change that stuff, fine. Okay, now it's immutable. They're going to be changing the wrong object, and the contents of the actual person class is like it's supposed to be, and that's immutable. Okay? So that's a consequence of pointers rather than using pointers rather than primitives. You copy memory addresses when you pass pointers around, which can result in aliases, which can give people access to stuff if you're not careful. Okay? Okay. Let's do a more complex example. Taken from, which will tie into the ingredient stuff that we did with the enumeration last time. So what we're trying to create is an ingredient deck. Kind of like the brass deck that you've been working with, both last week and this week. Okay? So I'm claiming that this will give us a fairly complete example of composition. Now remember, it's actually probably aggregation, but I'm going to call it composition. And no, I'm probably not going to ask you that on the test. Okay? If you say composition, that's good enough for me. Now, you may need to know what this term is, but I'm not going to ask you the difference between composition and aggregation. Okay? You can assume they mean the same thing. Objects made up of other objects. Okay, well, an ingredient deck is, of course, going to be composed of what?
Ingredients.
More specific, if we're talking about a deck of cards. Okay, I guess that was harder than I thought. Okay, it's going to have a bunch of ingredient cards. In fact, it's going to have an array list, just like in your lab, where you had brass deck. You had an array list of brass card. We're going to have an array list of ingredient card. Okay? So that still counts as composition. If you have one class that's composed of a collection of something of another class, that's composition. Now, obviously, ingredient cards can exist on their own. They don't have to be within the deck all the time. In fact, we're going to deal into players, and various stuff's going to happen with them. So it's really not composition, it's aggregation, but we'll call it composition. Okay, what's on the card?
How to make some.
Yeah, the ingredient. Remember last time we had enumeration that had mushroom and birdfoot and scorpion? So this is composed of ingredient type. Okay? But that's not all a card has.
A number.
Yeah, we could say it's got a number. Say again?
Quantity.
Actually, each card represents one. So I could have a hand that has several of the same card, but the card itself is not. Probably, if I want to show it on a screen, what's got to have? I want to display it as part of my GUI. Yeah. something called a draw image. So ingredient card is composed of two objects, in addition to probably some other primitives as well. And then finally, draw image itself has two components. One of them is the actual image, and the other one, which I wouldn't really expect you to guess, is a hotspot. So what I'm trying to do here is I've got some GUI classes that I've written to build a whole bunch of different types of board games. So if anything has an image, and it's supposed to appear on top of, as part of the GUI, of course it's got to have the associated image so it gets drawn. But I also want to know if the user clicked on it. So the way that we're going to be doing brass and all that kind of stuff throughout the semester, so if you want to select a card, you click on the card that you want. Then you click a button. If you wanted to do a build or whatever your action is, you click a token to select a token. So you're clicking on the various objects in the scene to execute the actions that you want to execute. Okay? So I have to be able to not only display the thing correctly, I have to have a mechanism for determining whether it got clicked on. And I remember it was either last semester or the semester before, I was using the word hotspot, and they were all like, what's that? We don't know what that is. So that was kind of surprising to me. If you have a hotspot on a web page, what you're trying to determine is, did the mouse click in that area? Okay, is it an active area of the web page? The same for a board game. There are certain, if the game is expecting me to select a card and I'm clicking all over the other locations, nothing's going to happen. Okay? So the cards are the associated hotspots that I'm wanting to detect. Did you click on a card? And then I can do something. Okay? So let's see. So now we're down at the level where pretty much as far as we can go. Because image is still probably an object made up of other objects, but it's one provided by Java. So I guess if we really wanted to look at the source files for Java, we could figure out all of its constituents. Okay? And we're not going to do that. In the case of hotspot, that's something that I wrote, and now we're at the level where we just define some primitives. Okay, I've got to know some basic numbers and do some basic math to figure out whether it's been clicked on or not. So let's take a look at that class and see if we can figure out what the various components are supposed to be doing. Let's see, that's going to be in Alchemists, where the ingredients are required. In fact, I probably already opened them. Yes, of course. Okay. So all a hotspot is a bunch of integers. So I will not use the term composition with this class. When you're composed of primitives and strings, we're just going to call that a low-level class. Okay? Even if this is a long list, as this is, a fairly substantial list of those primitives, strings and integers and whatever else, even if there's a bunch of them, because they're primitives and not objects, we're going to call that like, bottom level class, I don't know, nothing complicated. So it's not composed of anything. It's only if we start throwing in other more complicated objects in there that we're going to say that we're using composition. However, we still need encapsulation. We still have to protect the values of these primitives from being changed. Okay? I think I pointed out that we could, make this public. And then the user can change spot ID by saying object.spotID is equal to whatever. Okay? Now they may need to change some of these values. So that means we have to provide methods that allow those changes, and hopefully, because we force them to use methods, we can check to make sure that the values make sense. Okay? So you can see the constructor simply takes whatever values were given. In fact, I should probably do some checking here. I probably want my IDs to at least be positive integers. Okay, I should probably check for that, but I didn't. In fact, any of these numbers probably should really be positive numbers. Okay, we don't usually deal with negative widths or negative, well, at least when the GUIs, the way the board games work, X and Y coordinates are always positive. Okay, we could construct something to make negative X and Y coordinates. Okay, so I do allow the X value to change. So this is not an immutable class. If I want to change X loc and Y loc, which I need to be able to do, because when you click on certain items, they get moved around. Okay, you can put tokens onto the board. There's various things. I have to make it as general as possible. I have to allow the location for these things to be changed. Now, having said that, I've done all the stuff right here except for the fact I should at least do some basic checking here. And that would be what encapsulation really requires me to do. I force them to go through a method. That allows me to stick some code in here to check that that value makes sense. Okay? So in other words, I probably want a positive integer greater than or equal to 0, I guess. Then go ahead and update it. That still doesn't make it right. Okay? I could still have a bug that sets the hot X value to be something incorrect. And presumably that will show up when I try to use that card, and I'm clicking on the card, nothing's happening because the X and Y coordinates are wrong. Okay? So that check doesn't solve all my issues, but it's an obvious one that I probably should, for completeness, put in there. But you can see that I can set X and Y. I can also get the X and Y values. Okay? I can get the width and the height. I can get the left and the top of the image. And then more importantly, the most important method in here is that thing selected? So I don't want to show that code yet. We're going to work through it. But you tell me where the user clicked, and I'm simply, for every object at that particular point in time that might be clicked on to do something meaningful, I'm going to poll them and say where you clicked on, where you clicked on, where you clicked on, where you clicked on. Okay? So if I'm waiting for someone to click on a card, I've got 8 cards to check. Obviously, the first one that says, yeah, it was me, I can quit. Okay? But potentially, they missed altogether. They were clicking an entirely wrong section of the screen, and none of the cards report that they were clicked on. Okay? But I like for my objects, when there's something, if there's something in here that they have information about, I would like to write a method to let that object figure it out, rather than having some other class that accesses the X and Y, accesses X loc and Y loc, and figures it out somewhere else. Those are 2 different designs that we could approach. We could say, this class just keeps these numbers, and that's all it does. And we have another class, ask it for its X and Y location, and its width and its height, and figures out whether it was clicked on. Okay? My philosophy is I usually let the class that actually has the data do any simple computations that are required. Obviously, if it's something really complicated, I might not want to put it in here. Okay? But since we already have the numbers that I need for that computation, let's put the method that does the computation in here. All right, how does it work? Well, I keep track of a width and a height. Okay, those are numbers that are stored in this hotspot class. It also knows where it's located. So X loc and Y loc is the location in the GUI where this thing is supposed to be drawn. Okay? And then I come along and I click, click down here. So we've got X click and Y click. And I would like for this particular card, assuming that's what it is, to report that, yeah, I was clicked on. Okay, so it should return true once it does this simple computation. Okay. So we need to compute some differences. I need to know how far from the center was that click in both X and Y. Because obviously, in Another case, if this is X click and Y click, the card should return false. No, I wasn't clicked on. Okay? And it's got its own separate offsets in there. Okay? Let's go back to this first one. How can I determine that, yeah, the X coordinates are all right?
You take X loc and then width.
I'm going to need, yeah, so I need the difference between where the user clicked in X and where the center is, and do some kind of comparison with the width. How can I tell that the X coordinate for this particular spot is okay? Using those three numbers, X loc, X click, and width.
Well, assuming that for your X, you know, it's the very far left is 0 to whatever the width is, then you go width, if width minus X click is, I guess so it would be a positive integer, then you know that it was within the card's width and thus somewhere on the card.
You're on the right track. Okay? Yes.
You would find out if X click is between X loc and X loc plus width.
Right idea? Yes.
You would do something like X width, X click minus X width minus 2. And that would be the distance. If that distance is less than the width divided by 2,
Yes.
then you
Okay.
clicked in the region.
So I have to worry about a few things. I have to worry about the sign, which I prefer not to. I don't want it to depend on which one I decide to include first in my subtraction, because the sign of X loc minus X click is going to change based on where the click was. Okay? I know that all the coordinates themselves are going to be positive numbers because, you know, here's our entire GUI. 0, 0 is up here. So I like to deal with all positive numbers. Okay? So Y goes down, X goes across. All the individual coordinates are going to be positive. But the order that I subtract is going to depend upon where the user clicked. So I could end up with a negative number, and I prefer not to do that. Okay? Well, we have, as I'm sure you guys studied in 2100, an absolute value function. So I need to figure out the difference between where the user clicked and the center of the card is, and I want to discard the sign. Okay? So in other words, we're talking about this distance here. It doesn't matter whether I said X loc minus X click or X click minus X loc. I'm going to take the absolute value of that result. So in fact, the order I place them in here is irrelevant. But I do have to take their difference. Okay? And you can see as we're moving closer and closer to the edge, we're getting close to moving off that card. That difference is getting closer and closer to width over 2. Yes?
Why would you want to do this by using the center of the card as a reference point instead of one of the corners?
No reason. You could use the corners.
Okay.
Yep.
Seems like the corners would make the math easier.
In fact, in your defense, bringing it up, a lot of the built-in Java graphics libraries like to use left and top. Okay? I just found it's easier for me when I'm looking at the GUI and trying to work out stuff to think in terms of the center of that object. But yes, you can do left and top, and that's probably what you gave me the formula for, and in this case, that's right.
Okay.
Okay? Could have done that. In fact, there's a get left and a get top method that I provide in case I ever wanted to change it to that system. I could convert from my center system to that system. Good point. Okay? But if we're dealing with the center, which is what I actually stored, then that distance had better be less than or equal to width over 2. And the same must be true for the y's and height over 2. Both of those have to be less than or equal to actually correspond to a click that was on the card. Including, that only works for rectangular objects. Okay? But even if I've got circles and stuff, it's close enough. Okay? I imagine if I had some like potato looking thing, that might not work. But for rectangles and circular stuff, it's good enough. Okay? All right. So back to composition. Where on earth was that stuff? I think we were looking at the code, so yeah. So down here, so I've got a get hot left and a get hot top in case I wanted to use left top system. But down here, here's my test for what we were just discussing. And they both must be true, in which case I return true, otherwise I return false. Okay? And then the ID, that's all that's in there. So this class itself is not composed of other objects. So it would not fall, we're not using composition for it. We are using encapsulation, we're not using composition. Whenever we do use composition, we should also be using encapsulation. But you use encapsulation for both primitives and objects. Okay. So back to draw image. Now we're using composition. I've got two objects here. I don't really count strings, although maybe I should. But these two things are definitely objects. Okay? So to become a draw image, I have to have defined an area. Okay, that basically is supposed to be the outline of the image. And of course, the image itself. Okay? And where that image is going to be drawn depends on what is stored as the center of the hotspot. So you can see what have we got going on down here. So I need to, in my constructor, I need to set those, I need to create a hotspot. So another way that I can avoid any problems with the user having access to the objects that make this thing up, like we did with the address, is to just create the whole thing in here. If I create the object from scratch inside the constructor, no one else is going to have a reference to it, unless I give them one with the get method, for example, which I won't do. Okay? There aren't any tricky details that I have to worry about. Now, that's not true of the image. You can see all I did was copy it in there. Okay? But eventually we're going to get to the point where we start talking about classes that are closely related. We allow them to trust each other. This would be an example of that. I could go through all the rigmarole of creating a new image to prevent outside user from having access to that, but that's a lot of busy work. The items that are going to be using this draw image are probably going to be classes that I can trust. Okay? If someone's creating this thing in a main method, I probably don't trust them. But in this case, we're going to go ahead and say, yeah, I feel comfortable with having this alias created here because I'm pretty sure no one's going to go in there and mess with the image, although they could, and that would mess up the image that we're storing. Okay, they could make it all zeros and make it be a black image. Okay, so be aware of that. I may slide that into the exam, letting you get away with just doing the shortcut, but then saying, why could this be a problem? And then expect you to explain about the discussion that we had. Okay? By the way, I like to do that on exams. I'll give you a little bit of a code, and then there'll be some kind of analysis you have to do as a short answer. Okay? The exams that I come up with in this class always take me the longest to come up with. Okay, but I also had to set, here's the one that's the problem. Strings are not a problem. Okay, they're immutable. So the nice thing about having immutable classes is I no longer have to worry about that. Because even if I have a bunch of aliases to the same object, nobody can change it without creating a new object and pointing their pointer somewhere else. Okay? So since strings are immutable, that's why I guess that's why I've gotten in the convention of not counting them as composition, because they're simple, they have some primitive behaviors, and I don't have to worry about the usual problems with composition. Okay? So anytime that we can make a class be immutable, we should, because it simplifies a lot of dependencies when that class is immutable. So this line is not a problem. This line potentially could be. Okay? Now, another thing I have going on in this class, so I do have some additional primitives here. I want to be able to set the visibility on and off. In some cases, I may want this card to be drawn. In some cases, I want it to not be drawn. In fact, in Brass, when we click on a card and it goes up to that larger area, it's been a while since we did that, so you probably don't remember. But in fact, I don't think I moved the card anywhere, I just made it invisible. And then I made this other one be visible. Okay? So just by simple manipulation of that visibility variable, I can have the card be drawn or not drawn. And so that means that probably if the card is not visible, I probably don't want it to report itself as selected. If I'm clicking on an invisible card, I would prefer not to have anything happen. So I better check for that. And I do. Okay? So anyone that asks to see if the draw image is selected, of course, I'm going to turn right around and ask the hotspot if it's selected, but only if the card's visible. If the card's not visible to begin with, I'm just going to return false. Now, that brings up a really, really important point, which is going to be important for next lecture, so let me bring this. So we've got a bunch of new terms. Composition, aggregation, encapsulation is not a new term, but let's throw that in there. Here's one more. This is delegation. Okay? Remember what I said, I would like the hotspot to be in chart. It knows where its x-coordinate, y-coordinate, width, and height are. So it's in the best position to do the computation. Okay? Now I could do the computation here. I could get the x center, the y center, get the width and the height, and do the computation that we saw in the other class right here instead. Okay? But because I like to let the class that has the information do the job, it's nonsense for me to repeat that work here. So I don't. I know that the hotspot is the best one to figure out whether it's selected or not. So if it's visible, just ask it. I'm delegating the work to the other object. And with composition, that's really, really important. Don't reinvent the wheel. Presumably you built those objects with a lot of functionality, at least if they're well designed, they can do stuff. So if they're designed to do something, let them do it. Okay? So I guess we're trusting the hotspot to be able to get that computation correct. So a lot of times when you have a lot of levels of composition, the top level object doesn't really do that much. Its main job is to delegate the authority to whichever of its composing objects it's supposed to for that particular task. Okay? Maybe it adds on a couple of new things that those objects don't do, but for the most part, it's going to do a lot of delegation. And so we already seen an example here. Okay? And then if I want to show the image, in this case, not only am I getting ready to set the visibility to be true, which I do right there, I'm also going to be setting, I also want whoever is calling this show image method to tell me where that thing is supposed to be placed. So in general, I can move the cards around. I can show them in different locations depending upon what's happening. I don't think that happens. Okay? But in principle, I could. If I simply say show image and I give it a new location, that's where the thing's center will be located. Okay? So I update the center to be those values. I set its visibility to be true. So then it's going to be drawn at that new location. And if I decide I want to hide the image, just set its visibility to false. It's gone. Okay? I got some get methods to get back some values. Again, I'm using delegation to get the values out of the hotspot itself. And then finally, the draw method, where if the thing's supposed to be drawn, I'm going to use a built-in Java class to actually draw the image. So the only time the image thing is actually used is here. Okay? And oh, by the way, I'm using a built-in object. It does not want to use my system. It wants to use the left top system. Okay? So based on wherever the center is, I can get the left top out and provide it to the graphics class that Java has written for me already, and it gets drawn there. Okay? So I found it convenient to provide those methods in the hotspot, even though for my computations I was using the center. Okay, what's next? All right, so we got this far. So now finally we're ready to look at ingredient card because we already saw ingredient type last time. It's an enumeration, which as you saw is a class with a lot of stuff. Okay, so let's look at ingredient card. I don't have that open yet. Okay? It's composed of both of those objects. So here's another example of composition, and presumably I'm going to do some delegation in here as well. Okay? So notice the constructor, however, I pass in the image here, because to create the draw image, of course I need the image. Okay? So when you were working on your lab 2 and you saw that the constructor in brass deck, brass card or brass deck, all that construction code, essentially what I'm doing is I'm saying this card needs to have that image, that card needs to have that image, place it here. You know, there's a lot of stuff that had to be set. So that can be busy work, you know, making sure that each image is applied to the correct card. And that's why the constructor is so long. It's not really doing anything meaningful, except for really the same set of code, making sure that all the objects are created correctly. Okay? But here's another example of where I don't know, because I'm creating the draw image inside here, no one else is going to have access to it. Okay? Not true of ingredient type. So that gets passed in and copied in here. Okay? So that's going to suffer from the same risk that we saw with the inside the draw image with the image object. Okay? If I want to determine whether this ingredient card was selected, I'm going to use delegation. I ask the draw image, were you selected? Which, of course, the draw image asks the hotspot, were you selected? Okay? So it tends to, you can, if you use composition correctly, you can have what would probably have seemed to have been a complicated operation be a simple case of delegation. Okay? I need to show the image, so I give it the X and Y coordinates where I want to show it. If I'm hiding it, then I hide it. If I draw it, I use delegation. Okay? I just pass along the graphics object to the draw image thing and let it get drawn from there. So when you guys, so something you could have done on the lab, just add it down here, to draw the deck, you could have said something along the lines of that. Okay? You're using delegation. Let's not worry about the details of drawing. Now, you had to do some other stuff, like get some random locations and stuff. So there was some other code that you had to do. But in principle, this would have been sufficient to draw the entire deck, all the cards in it, if you didn't already deal them out and get rid of them. Okay? That issue come up a few times. Nothing was showing up because inside your draw method, you had dealt out the cards, gotten your random numbers, and told the cards to draw themselves. But of course, so I'll take that back. You had already dealt them all out in the constructor to show their output. So by the time you got to the draw method to draw the cards, the deck was empty. Okay? And there was also this weird issue. Let me go ahead and talk about that. We've got a couple of minutes left. And this is something that I've struggled with trying to figure out why it does this several times in the past and never really got anywhere. If you've got a graphics application like Brass, and the window comes up initially, of course it's automatically calling the draw method for you, so it paints in all the stuff that's supposed to be painted in. It fills the window with its contents. For some bizarre reason, that's always called twice. Okay? So if you had read exactly how I told you to do that drawing stuff, you would have avoided that problem because you would have generated all your random numbers in the constructor. Okay? But if you're doing a bunch of work inside the draw method, then it mattered whether draw was called once or twice. Because the first time, you deal out all the cards. So now your deck is empty. You come back in there the second time, there's nothing to draw. You draw the board again, covering up all your correctly drawn cards, and now the board doesn't have anything on it. Okay? So keep that in mind for the initial time that the window comes up. Java likes to draw the entire contents twice. Okay? I've had that lab, it's like the third or fourth time I've done that lab, and I don't think that's ever been No one has ever been to my office for that before. So in fact, it took me a good half an hour to figure it out the first time. Okay, I had completely forgotten all about it. But if you actually did the stuff that I said, do some of this stuff in the constructor, it kind of avoids the problem. Okay? So it was, when I first wrote it, of course, I had to deal with that issue, but then subsequently I've forgotten all about it. But that's what happened there. Okay? And so finally, to tie in what we're going to do with next time, wasn't that not much new to talk about here, is ingredient deck, which is going to be obviously not here. Ingredient deck. Okay? It's a collection class. That happens a lot. We frequently, you're just not going to get away from that data structure stuff. You frequently have a class whose instance variables are collections of other objects. So this is definitely still composition. Okay? Our composition is ingredient card. But we've got 3 lists that contain varying amounts of them. Because for this particular game, I have to keep the discarded ingredients because the deck runs out frequently as players use up all the ingredients. So when the shuffle deck is empty, I have to take all the discarded ingredients and shuffle them back in to create a shuffle deck. Okay? So I in fact have to keep track of what's been discarded, what's still part of the deck, what's been discarded, as well as also keeping track of the completely unshuffled deck, all the original cards. So that happens a lot. So the next thing we're going to talk about in class tomorrow is dealing more with collections themselves. Although 95% of the time, actually I think I usually say 90% of the time I use array list. The remaining 10%, 8% of that I use a priority queue. And then the last 2% is all the other junk that you learn in data structures. So we're going to talk about priority queues tomorrow. See ya. I mean Wednesday.